Problem 2. It says to solve the following system algebraically and verify your solution graphically. So here we're going to have a slightly more complicated system of equations than we did in problem 1. And we're going to have to take it one step further by verifying our solution on the graph, just by sketching out a graph. So we're going to use substitution again for this problem. We already have our y isolated, so we're going to plug this value of y here into our second equation. So we're going to get x squared plus negative 2x plus 2 squared is equal to 9. We're going to FOIL this out, square that, and we're going to get x squared plus 4x squared minus 8x plus 4 is equal to 9. Now if we simplify this, we have x squared plus 4x to get 5x squared, and then minus 8x, and then we have our plus 4 here, and we're going to subtract 9 from both sides to get a negative 5 on this side is equal to 0. And from here it's simple. Same thing that we've been doing in our past couple of problems. We're going to go x is equal to 8 plus or minus, using the quadratic formula here, of course, plus or minus negative 8 squared minus 4 times a c over 2a. So of course quadratic formula is going to be negative b plus or minus the square root of b squared minus 4ac over 2a. Our a value is 5, as we can see. Our b value is negative 8, and our c value is negative 5. So if we plug that all into the quadratic formula, we get this. If we simplify this out, we get that x is equal to 8 plus or minus the square root of 164 over 10. And then we just have to plug into our calculator from here to find our x values, which is going to be x is equal to 2.08 and negative 0.48. So then we take our x values of 2.08 and negative 0.48, and we're going to simply plug them back up into our equation here of y is equal to negative 2x plus 2. So when x is equal to 2.08, we're going to have y is equal to negative 2.08 plus 2, which is equal to negative 2.16. And then when x is equal to negative 0.48, we're going to have y is equal to negative 2, negative 0.48 plus 2, which will give us a y value of 2.96. So our solutions, two solutions, are going to be the ordered pairs 2.08 comma negative 2.16 and negative 0.48 comma 2.96. So here we're going to have to verify the system, the solution graphically. So we're going to simply sketch out our two equations here on our system, and the solution to that system of equations will be where the graphs intercept each other. So let's look here. Our first equation is negative 2x plus 2. So if we plug in values real quick, 0 is going to put us at 2. Our value of 1, if we plug in 1, negative 2 times 1 is negative 2 plus 2 will be 0. If we plug in negative 1, we will get 4. So we can see this is a simple linear equation. It's going to continue in that pattern. It has a slope of negative 2, a y-intercept of positive 2. So then our second equation is a little more complicated. But if we look at it, we can see that it is a circle equation. X squared plus y squared is equal to 9. So that means we're going to have a circle with its center at the origin and a radius of 3. So if we sketch this circle out, something like that, doesn't have to be perfect, we can see that we have a solution at approximately negative 0.48 and well, should be 2.96 here. So that one makes sense. And we have another intercept at 2-ish and negative 2-ish, which will get us our 2.08 and negative 2.16. So our drawings don't have to be perfect. They don't have to intercept at precisely 2.08 and negative 2.16, because that's very difficult to do by hand. But we can see here, just by sketching it out, that our solutions are accurate and verified by our graphing.